Welcome to the Crazy Hat Chemist, so another video on solutions and their behaviors. BAM! Today we're going to calculate concentrations in parts per million. That's ppm. So here's our example problem here. If you have 4.5 milligrams of copper ion in exactly 2 liters of water, what is the concentration of copper ions in parts per million? So this is a very excellent applied problem. So look up in your city or county your water quality report. In your water quality report, it will let you know the amount and concentration of ions typically in parts per million or parts per billion. Hopefully after doing this problem you can figure out the parts per million and then therefore the parts per billion as well. And there's a limit as the number of ions and type of ions that you can have in your water for it to be clean drinking water. Check it out. Go up to your city or your county and look up what it is in your area, and they should give you a printed report. So a very applicable problem here. So parts per million is the following. You're going to take your grams of solute, that's going to be your numerator term. You're going to take your grams of solution, that's going to be your denominator term. And then if it's parts per million, you're going to times that or multiply it by 1,000,000. If it's parts per billion, you're going to multiply by 1,000,000,000, and that will get you parts per billion. So right now we're doing parts per million. Okay, so remember that the solution is equal to the solute plus the solvent. Okay, the solute is in the lesser quantity, the solvent is in the greater quantity, and the sum of those two is equal to the solution. So the solute, lesser quantity, solvent, greater quantity, and the solution is the sum of the two. Okay, we're going to take our 4.5 milligrams of copper ion and convert that into grams of copper ion. Okay, so that will be 0.0045 grams of copper ion. So remember that milligrams and grams, that's a conversion between 1,000, just like a kilogram and a gram. Okay, we're also going to take our liters, and we're going to take those liters of water and convert that into grams of water, knowing the approximate density of water, which is 1 gram per 1 mil. Now, depending on the temperature, this number might vary, but this is really an excellent close approximation. So we're going to take our 2 liters, convert it to milliliters, and then from milliliters, we're going to use the density of water. That's 1 gram per 1 mil. That will give me the grams. So now I have 2,000 grams of water. So hopefully you can compare the copper ion mass of 0.0045 compared to the water mass of 2,000 grams of water and figure out which one is the solute, which one is the solvent. Obviously, the solute is the copper because it's in the lesser amount, and the solvent is the water because that's in the greater amount. Now we're going to take that equation that we have there at the very beginning, that's parts per million. The solute is going to go in the numerator, and the solution is going to go in the denominator. The solution is the sum of the solute plus the solvent. Okay, so the parts per million is equal to, in the numerator, I got my solute of 0.0045 grams of copper. In my denominator term, I have the solution. That is the sum of the solute, 0.0045 grams of copper ion, plus the 2,000 grams of water. And that is the solution. Now we're going to multiply that by 1,000,000, and that will give me parts per million. So this is 2.2 parts per million of copper ions that are in this solution. So I want you to go check your water quality report and figure out the number of copper ions or maybe the lead ions in your water system. Okay, see your county, see your city for that. Okay, I am the Crazy Hat Chemist, and of course I got another crazy hat. Okay, and this is a chicken. I have my head up the chicken's, you know what. Okay, which came first, the chicken or the egg? Okay, give me a thumbs up if you like that video. Subscribe to my YouTube channel, and there's a chicken run. See you later. Bye now.